This is the Unit 2, Topic 1, part of the semester exam review for Algebra 1. And again, I'm starting with the front of the review packet because I want to remind you that on the exam, you're going to get all of these formulas. And you may not need to use them, especially in this section, but you never know, and it's just important to remember that they are there for your assistance. Question number 22. The graph below shows the price of a cheese pizza with up to 4 toppings. Notice that they underlined that. And whenever they bold or underline something on your exam, that means it's really important. So here we have a graph, and notice that it says number of toppings and the price of a pizza. So each of these data points deals with how many toppings, 0, 1, 2, 3, or 4 toppings, and how much the pizza costs. The first question says, use the phrase is a function of to describe the situation. Well, if you remember from what we taught in class, you always have the dependent variable, which is a function of the independent variable. Remember, the dependent variable is the y. It's what depends on your x. So the price of a pizza depends on the number of toppings. I always, I taught my students that if you have an ex-boyfriend or girlfriend, you are now independent of the person, keyword x. So independent is the x, dependent is the y. So use the phrase as a function of to describe the situation. We're going to say the price of a pizza, that's your dependent variable. The price of a pizza is a function of, which is what they asked us to write, is a function of, and then the independent variable, which is the number of toppings. So the price of a pizza is a function of the number of toppings. Now they want us to use function notation to describe the point 2, 12.50. Function notation is that f of x, the g of x. You can use whatever letters. So I'm going to use p because price. The price when x is 2, so when the number of toppings is 2, equals $12.50. You don't need to put units on it. This is just straight function notation to represent that point. Next, what is the domain of this function? The domain is the set of all x values that have a y value. Now, because we're talking about number of toppings, we don't have points in between. It's not a continuous function. So we're going to put our set notation, which is our little brackets, and list all the x values, which is 0, 1, 2, 3, and 4. Put a bracket at the end, and that is our domain. Now, do these points describe a linear function? Why or why not? So let's look back, and linear means that it can make a line. But if we look at this, this would be a line, but instead this curves. So we would say that it is not a linear function. Why or why not? I'm going to say no. Because, if you remember to when we talked about linear, because there is no constant rate of change. Remember, constant rate of change is what tells us if something is linear. We can see this because from 0 to 1, so from 0 toppings to 1 topping, it increases by $1. From 1 to 2 toppings, it increases by 75 cents. So that right there shows us that it is not a constant rate of change, because for it to be constant rate of change, it would have to go up by $1 every time. So we can see from 1075, which was 0 toppings, to 1175. That increased by $1. But 1175, it would have to be at 1275 for it to still be a constant rate of change. It is not, and therefore it is not linear. Finally, what is the range of this function? The range of this function is all of the y values. So again, because it's not continuous, we're going to put braces around it, and we're going to list all of our y values. So we have 1075, 1175, 1250, 13, and 1325. Sorry about my handwriting on this. And that is our range. Our next question is 23. You are playing a carnival game. You now have 50 tickets. Each time you win a game, you will get 8 tickets. When you get at least 100 tickets, you will stop playing. The function t of w equals 50 plus 8w represents the total number of tickets that you have after winning w games. So the first thing they want you to do is fill in the missing values in the chart below. So if we have this formula, t of w equals 50 plus 8w, first thing I want to see is t of 0, because w is going to be 0. So I'm going to have 50 plus 8 times 0, which is going to be 50 plus 0, which is just 50. So I can fill in the first one with 50. The next one, w, is 2. So 2 goes in the place of w, and everywhere in the function we see w, we replace it with 2. So 50 plus 8 times 2 is going to be 50 plus 16, and that's going to give us 66. So I can fill in 66. The final one, though, says t of w equals 82. So this whole part right here is going to be replaced with 82. So 82 equals 50 plus 8w, and then I'm going to solve for w. So the first thing I'm going to do is subtract 50 on both sides, and 82 minus 50 is 32. These cancel out, and we have 8w. So then to solve for w, I'm going to divide both sides by 8, and w is going to equal 4. So when w is 4, t of w equals 82. The next part is, what are the independent and dependent variables? Remember, independent is the x, dependent is the y. It also comes first in a chart. We can also see that our x is what's inside the parentheses. What's outside the whole thing is our y. So our independent is our w, which is number of games won. You want to be more specific than just w. You want to state exactly what it is. Our dependent is t of w, which is the number of tickets. So number of tickets is dependent on how many games won, because remember, you win tickets every time you win a game. Our next question is, write a statement using is a function of for the situation. So we just did it with the last one. Remember, it is the dependent variable is a function of the independent variable. So the number of tickets, because that's our dependent, the number of tickets is a function of the number of games won. And this is our is a function of statement. The next question, are the variables discrete or continuous? Why? Well, remember, discrete means that it's individual points. They're not connected. So you can't have points in between. And we're going to say that the variables are going to be discrete. This is because the number of games won and the number of tickets can only be whole numbers. So let's write this. The number of games won, because remember, I can't win. Ooh, sorry. The handwriting. The number of games won and the number of tickets. So this is our dependent and our independent variables. Number of tickets can only be whole numbers. We can't win half a game. We can't win half a ticket. So that might also be important to state why. You can't win half a game or get half a ticket. All right, next. What does the statement T of 3 equals 74 mean in this situation? So remember, T of 3 is our number of tickets, as you can see up here, and W, which is on the inside 3, is the number of games won. So this is going to be the number of tickets you have after winning 3 games is 74 tickets. The next question says complete the domain 0, 1, 2. Now, if we go back to the original question, it says when you get at least 100 tickets, you will stop playing. So I think it's important for us to figure out what W is when we have 100. So remember, our equation is originally T of W equals 50 plus 8W. And what we're going to look at is to see, well, when that number of tickets equals 100, what is W? So the first thing we're going to do is subtract 50 on both sides. I'm going to move over to the side, but 50 equals 8W. Then I'm going to divide both sides by 8. And what I'm going to see is that W equals 6.25. Now, if you think about it logically, after 6 games, they still won't have 100 tickets, or you won't still have 100 tickets. You have to play more than 6 games. So what we can see is that we're going to stop after 7 games. All right, and therefore we can fill out our domain as 0, 1, 2. Now remember, these are only whole numbers. 3, 4, 5, 6, 7. We're going to stop at 7 because they stop after you've won at least 100 tickets. Finally, what number would replace the variable W in the statement T of W equals 90? So if we have T of W equals 50 plus 8W, what we're looking at is what is W when T of W is 90? So the first thing we're going to do is subtract 50, and 90 minus 50 is 40, and then 40 equals 8W. So to solve for W, we divide by 8, and 40 divided by 8 is 5. So what number would replace the variable W in the statement T of W equals 90? Well, when W is 5. The next question gives us a graph. We've got a couple points. They show us that the scale is by 1. And so the question says, which of the following points, if added to the graph above, will cause the relation not to be a function. So notice that that is in capital letters, not, and that's key. So what I'm going to do is I'm going to plot these points and see. So the first thing we have to know is, what is a function? A function is when every x has only one y. This also on a graph can show us when it passes the vertical line test, meaning that if I drew a vertical line over each one of these, my vertical line will only intersect one point or no points. But if it intersects 2 points, then it's not a function. So if we first plot A, that's 1, 2, I'm going to go over 2 spots from the origin and up, 1, 2, 3, because x comes before y. There's our point A. Well, there's no other point when x is 2, so A doesn't work. Next I'm going to do B, which is 1, 2, 3, 4, and up 2. So that's right here, that's B. There's no other points when x is 4, so that won't work either. Because we're looking what's going to make it not a function. If I go over 1, 2, 3, and down -2, C is going to be right here. And we can see that when x is 3, there are 2 points. And so if I inputted 3, my output, it wouldn't know whether to give me 0 or -2. So this point C makes it not a function. But let's just double check the last point. We've got 0, 1, 2, 3, 4. -4 is right here. D, that's still a function. So we know our answer is going to be C. All right, our next question. Which of the following statements is true about the statement f of 5 equals 12? So the point 5, 12 is on the graph of the function f. Well, we can see that inside the parentheses is our x, outside the parentheses is our y, so 5, 12, this would be true. Let's just check the other ones just to be sure. I always recommend that you do this in case you might have actually made a mistake. The number 5 is an element of the range of f. Well, 5 is actually in our domain, so this can't tell us, this can't tell us anything about that being true. And then C, 12 would be the value of the independent variable, and 5 would be the value of the dependent variable. Well, remember that independent is our x and dependent is our y. So this would be our x and this would be our y. But in this, 5 is our x, 12 is our y. So C can't be true either, which means that the answer is A. Question 26. If f of x equals 3x minus 2, what is the value of f of 5? Well, this is telling us that x is 5, so f of 5 is going to equal, anywhere where we see an x, that's going to be a 5. So 3 times 5 minus 2. Well, 3 times 5 is 15, and 15 minus 2 is 13. So f of 5 equals 13, which is B. Question 27. Sketch a graph on the axis below for a function f of x with the following characteristics. So the first thing it tells us is the function has x-intercepts of -3 and 2. Remember that x-intercepts are where it crosses the x-axis. So here is our x-axis. So -3 is going 1, 2, -3 to the left, so we've got that point, and we've got 1, 2 to the right, so we have that point. So our x-intercepts are -3 and 2. It also tells us that our y-intercept is 3. Now remember, our y-intercept is where it crosses the y-axis, which is this. So we're going to go from the origin up 1, 2, 3. So we've got a point right there. So we've taken care of this one, we've taken care of this one. Next thing we know is that f of -4 equals -5. Remember, this means that this is our x, this is our y. Therefore, we can write the point -4, -5. For f of 4 equals -3, we can write the point 4, -3. And we know that those are going to be on our graph. So I'm going to go from the origin 1, 2, 3, 4 in the negative direction and down 1, 2, 3, 4, 5 so that we have a point right here. And then I'm going to go over 4 in the positive direction, 1, 2, 3, 4, and then down 1, 2, 3. And that's going to give me this point right here. So we've taken care of this. Next, the function has a maximum value at the point -1, 4. So I'm going to go over -1 and up 1, 2, 3, 4. And that is going to be my maximum point. Therefore, I know that I'm not going anything higher than this point. So we've taken care of that one. The function is increasing when -4 is less than or equal to x, which is less than or equal to -1. This means that as you read left to right, it's going up. So increasing, decreasing, because we always read left to right. So what I can see is that from -4, which is right here, all right, to -1, which is right here, this part's increasing. So reading from left to right, it increases. Now also keep in mind that it says the domain of the function is from -4 to 4. So I know that this is going to be my final point and this is going to be my final point. I'm not continuing on. I'm not drawing arrows. I also know that I'm connecting it because the function is continuous. Now the last part says it's decreasing when -1 is less than or equal to x, which is less than or equal to 4. So from this point, I'm going down. And therefore, I've taken care of that. It's increasing and decreasing. I've taken care of the domain, and I've taken care of the fact that it's continuous. Yours might not look exactly like mine, depending on the way you drew your curve, but it more or less should look like this. And if so, you've done this question correctly. Question number 28. During a storm, the power in a house went off and on over a 7-hour period. The graph represents the temperature C in degrees Celsius inside of a freezer as a function of time. The variable T represents the time in hours since the power first went off. So we can see that here's our degrees, started at -2, went up to 3, so this is probably while the power was off, but then it started to drop back down, went all the way down to -3, so this is probably when the power went back on. And then as it started to get warmer again, that's probably when the power went back off again. So our first question is, what is the domain of the function? Remember, domain is our x, it's our time in hours, and because this is continuous, we're going to have to write our answer in inequality form. So I always like to write my smallest value to my largest value. So my smallest value is 0, my largest value is 7. And all of my domain, all of my t, time and hours, you need to use the variable they give you, is in between these two values, including 0 and including 7. So we have to write 0 is less than or equal to t, which is less than or equal to 7. Next, what is the range of the function? Range is our y's, so we have to find our smallest y, which is right here at -3, and our largest y, which is at 3. So our range is going to be from -3 to 3. And because we're dealing with c, -3 is going to be less than or equal to c, which is less than or equal to 3, because it does include those 2 points. Next question, what is the meaning of the c-intercept? The c-intercept is where it crosses the c-axis, which is our degrees. So our c-intercept is -2. And that's going to be at at time 0. So the meaning of the c-intercept is the temperature when the power first went off. So it first went off at negative 2 degrees Celsius. So the meaning of the c-intercept is the temperature when the power first went off, which is negative 2 degrees Celsius. The next question is, at what time t is the minimum temperature reached? So the minimum temperature is our smallest value, which is right here, at negative 3 degrees Celsius, and that was reached at 6 hours. So at what time t is the minimum temperature reached? It's reached at t equals 6, so, sorry, not when. So it represents 6 hours after the power first went off. So 6 hours after the power first went off is when the minimum temperature was reached. The next question, on what interval of time is the temperature decreasing? So again, as we read left to right, this is increasing, increasing, increasing because it went up. Here it's decreasing, but then it increases again. So from t equals 3 to t equals 6, the temperature is decreasing again. So again, my smallest value is 3, my largest value is 6, and every time in between that is the interval of time at which the temperature is decreasing. Finally, what does the statement C of 5 equal negative 2 represent in the context of this situation? So remember that this is our x, this is our y. So this is our t, and this is our c. So what it represents is 5 hours after the temperature first went off, the temperature of the freezer was negative 2 degrees Celsius. When you're giving questions like this, please don't forget to use your units. Okay? Question number 29. For each relation below, determine whether or not the relation represents a function. Justify your answer. So remember, we're looking for a function, which means that for every x, there's only one y. When we look at graphs, we can do the vertical line test to see if there is ever a point at which a vertical line crosses the graph at more than one point. With question A, it does not, so the answer will be yes, it's a function because you can say it passes the vertical line test, but it's really important to use the definition. So I think, yes, it's a function because every x has only one y. You can say for every element in the domain, there's only one range value. For number 2, or B, if we make our vertical line, already we can see, like right here, at 1 to negative 3, there are 2 y values. So there are multiple places where there's an x value that has more than one y value attached, which means it is not a function. You want to be specific as to why it's not a function, so No, it's not a function. Because there are x values that have more than one y value. And I would be specific. I would say, I'm going to write it up here, but examples include x equals, when x equals -3, when x equals 1, when x equals 2. So I think it's important to give examples to justify when it is not a function. Okay, for C, we have 2, 7, 4, -7, 2, 12, and 6, 11. Well, because of these 2's here, this is not a function. So no, it's not a function because when x equals 2, there is more than one y associated with it. All right, D. 4, 9, 6, 11, 11, 15, 10, 9. So this is a function because every x has only one y. I would not write because none of the x's are repeating. You really, when you're saying yes, it is a function, use the definition of a function to help defend your answer. So yes, it's a function because every x has only one y associated with it. All right, finally, E and F. E and F are mappings. And if you remember with mappings, here's your x's, here's your y's, and each x will go to a y, and that will make up an ordered pair. So we have 4, 2. We have 5, 4, 5, 8, and 7, 9. And because of mappings, we can see with this one that it's very clear this is not a function. So no, it's not a function. Because when x equals 5, there is more than one y value associated with it. And I forgot to, oh, sorry about the handwriting. I forgot to do this with the problem above, right up here, but it would be best to say, give an example, y equals 4 or y equals 8 when x equals 5. Finally, we have F, and we can see 4, 5, 8, 7, 1, 9, 2, 9. Don't let this throw you off. They could all go to the same y value for all you care. What you care about, just like in in E, is that an x only goes to one y value. It doesn't matter what y value they go to. So we can see with the mapping that each x only goes to one y. So yes, it's a function. And it's a function because every x has only one y value associated with it. And we are done. The graphs of two functions f of x and g of x are shown below. So we can see g of x is labeled with this curve and f of x is labeled with this line. What they want you to do is write the correct symbol less than, equal, or greater than in the box between the two statements. So let's look at the first one. F of 2 box g of negative 1. Well, when f of 2, that's on our straight line, so 1, 2, 1, 2, 3. So f of 2 equals 3, and g of negative 1, that's this curve, that's negative 1 is right here, so 1, 2, 3 is going to equal 3. So what we can actually see is that these are equal to each other. Next we have the x-intercept of f of x. So x-intercept of f of x, sorry, that's the straight line, that hits the x-axis right here, which is at negative 1. And then the y-intercept of g of x. So here's g of x. The y-intercept is where it crosses the y-axis. So 1, 2, 3, 4. So which one's larger? The y-intercept of g of x. So the x-intercept of f of x is going to be less than the y-intercept of g of x. Finally, we have f of 1 times f of 3 and g of negative 1 plus g of 2. So let's first find f of 1 and f of 3. Here's our, here's our straight line. F of 1 is 2. So I'm going to write that. F of 1 is 2. And then we need to find f of 3, which is 1, 2, 3, 1, 2, 3, 4. So f of 3 is 4, and 2 times 4 is 8. Next we have g of negative 1. G of negative 1 is 1, 2, 3. So I'm going to write that. That's 3. And then I need to find g of 2, which is going to be 1, 2, 1, 2, 3. So it's going to be 3. And 3 plus 3 is 6. So which one is larger? 8 or 6? 8 is larger, so therefore f of 1 times f of 3 is going to be greater than g of negative 1 plus g of 2. For our final question of Unit 2, Topic 1, we have question 31. Two functions, f of x and g of x, are represented below. So we're given a table of values and we're given a graph. This is f of x, this is g of x. What we're going to be doing is comparing the columns, the statements in columns A and B. Write the column letter A or B of the expression that has the greater value. If both expressions are equal, write equals. So notice that greater is underlined, so that's the key word. Some of you are not reading carefully enough and are making careless mistakes, like writing which one's lesser or greater when it wants the opposite. So question A, f of 1 or g of negative 3. So we're going to look at our table first, and f of 1 is when x is 1. So that means f of 1 is 2. So this equals 2. And then g of negative 3 is when x is negative 3, and that equals 1. So which one's larger, 2 or 1? 2 is, so column A. Next we have the maximum value of f of x. So remember, maximum value, that would be the y value. So we're looking which y value is the largest, and that's going to be our maximum. 5, 6, 9, 8, 2, 0, negative 10. So 9 is going to be our largest value. So this is going to be 9. And then the x-intercept of g of x. Well, that's where it crosses the x-axis. It crosses it at negative 2. So which one's larger? A yet again. Next we have f of 0 minus f of 4 divided by 4. So first of all, f of 0, remember that's your x value, so that's going to be 8, and f of 4 is 0, so what we have is 8 minus 0 all divided by 4. Well, that's 8 divided by 4, which equals 2. Next we have g of 2, which is 1, 2, so that's 1, 2, negative 3, times g of 4, which is 1, 2, 3, 4, negative 2. So negative 3 times negative 2, that's going to be 6. Therefore, b is the greater value. Next we have the value of x that makes f of x equal to 0. So looking back at our table, the value of x that makes f of x equal to 0 is when f of x equals 0, that is 4. So the value of x that makes f of x equal to 0 is 4. Next we have g of negative 5 plus g of negative 3. G of negative 5 is 1, 2, 3, 4. Here's negative 5, so 1, 2, 3. So we've got 3 plus g of negative 3. So 1, 2, 3. So 1, negative 3 is right here, and that's at 1. So g of negative 3 is 1, and 3 plus 1 is 4. Well, 4 and 4 are equal, so we're going to say that they're equal. Finally, a plus b if f of a equals 5 and f of b equals negative 10. Well, f of a equals 5, we're looking for the value of a that makes f of a equal 5. So where does f of x, remember we're just inserting a here and a here, equal 5? It equals that at negative 8. So a is going to equal negative 8, and then f of b equals negative 10. So where does f of b equal negative 10? Equals it right down here. So x is 7, which means b is 7. So b is going to equal 7. And what we're looking for is a plus b. So negative 8 plus 7, which is going to equal negative 1. Finally, we're looking for g of 4. So g of 4 is 1, 2, 3, 4, and down 2, so negative 2. So g of 4 equals negative 2. And which one's larger? Well, negative 1 is larger than negative 2. So we're going to say column A. And that ends Unit 2, Topic 1 of the Semester Exam Review Packet.